people from the USA and in Europe and that, they said, can you record it, because they want to attend but they can't stay up that late or whatever.
They're obviously not fit and young like you, Paul.
Touche. I don't know about fit. They're definitely not young. Definitely not fit either. So I've got somebody unknown, and unknown has joined. So sorry to hear about that from your family and naming you unknown, but that's the way it is. So we've got 15 or 16 in now. We'll just wait another minute or two and then we'll make a start. I know some of you were tuned in last couple of weeks ago on the first presentation. Those of you who didn't, we talked about stuff. We're going to go over it on the, just a little bit of refresher. All right, it's 5 past. We're all pilots. We should be on time. So can I ask everybody to just mute their microphones? Thanks. And maybe even turn your videos off so we can save some bandwidth and stuff like that. That would be good. And we'll go through and see if I can't make this thing work. I'm gonna share. Actually, I'll just cancel that. Oh, the Intrepid Aviator has joined us. Now I'm curious. Welcome, Intrepid Aviator. We're all muted our microphones, but welcome. I am going to attempt to start this presentation, and here we go. We'll go to previous. So everybody can see this picture on the screen.
Yep,
there.
sure can.
Excellent. Rightio. Well, we'll make a start, and I'm gonna move that over here so that I can do this. Rightio. So for those of you who have joined us and they weren't with us last week or 2 weeks ago, a little bit about myself. From a maintenance background, I did 16 years in the Air Force. Then I went to the Royal Air Force of Oman as a maintenance planning specialist. Transferred all their paper records to full electronic records. 6 years in Canada. Spent time with my lovely wife, who's the chief flying instructor of the RA part of our school. 8 years doing FIFO up in PNG, and then worked in Australia, contracting to Qantas, and all the while doing our GA stuff. Started up a company, Flight Safety Solutions, to help aircraft owners and operators, sport and recreational maintenance training, and fully compliant aircraft record system that's CASAR 43 ready. From an operational point of view, grade 1 flight instructor with all the bits and pieces there. RAOS flight instructor, previously CFI, but Karen's taken over from that. I used to be a gliding instructor, tow pilot, and chief pilot of the banner tow operation for our other company. So 2 weeks ago, we talked about what is a stall. That is recorded and available on the Bad Attitude Advanced Flight Training YouTube channel. You can click that and have a look at what we talked about there. We basically talked about 3 contributors to a stall, being angle of attack, speed, and load, not just airspeed, what everybody thinks it is. We talked a bit about students' perceptions of what angle of attack is, and we had a rather in-depth discussion how some people think that the relative airflow is always from the horizon. We looked at that in depth and talked about it from an instructor's point of view about using correct terminology. Hi, Stuart. If you put yourself on mute, mate, that'll be good. Thanks for joining us. We talked about the definition and using a discussion point about the wind, because a lot of students think that it's always from in front of us because that's where the wind's blowing from, but we know that that's not the case. And because that was such an interesting little exercise, I actually did a Google search for pictures of reducing the angle of attack. I'm going to just let a couple of people in, and Reagan Lancy. Sorry, we just got somebody who sent me a message via Karen, and I'm just going to try and get him a link. So basically what I did here is did a Google search, and this is the top 3 lines of the pictures that Google shows up. And you can see that most of these here all have reference to the relative wind, the word wind, and it's all horizontal. Everything is horizontal. Now, if I take out all of the pictures here that show the relative winds horizontal, it's going to look like this. So that leaves us 3 pictures and a angle of attack graph. The bottom left-hand one over this side shows that the direction of travel of the aeroplane is this dotted line with the angle of attack, but it doesn't say that the relative airflow over the aerofoil is opposite to the direction of the flight path. This is the same one here. Angle of attack velocity doesn't show the relative airflow. So the best one that I could find was this one here. And if I blow that up, we can see that if we're in a climb, the direction of travel of the aeroplane is in this direction, and the relative airflow will be exactly opposite. So this one isn't exactly as good as what it could be, but at least it shows you in a descent the angle of attack and the relative airflow not being horizontal. So we talked a lot about that. Then we went on to talk about the angle of attack graph versus lift, and talked about how there's this equal amount of lift each side of the critical angle, but it's the drag, the increasing drag that's exponentially increasing, that actually causes us to stall. The aeroplane can't sustain the clean airflow. So we talk more about that, and that's more detail. For those who didn't see it last week, you can see that. We put the end to the myth of airspeed being the reason why we stall, and we talked about information that keeps us thinking that it's all about airspeed, because the Cessna 172 SPOH tells us that this is all about airspeed, including different flap settings. However, it's only published for wings level at 1G, and pilots should remember that level flight 1G published stalling speed is only valid for unaccelerated 1G flight, coordinated flight, typically gross weight, typically forward C at G. We then talked about G loading and its effect on the angle of attack and the stall, and talked about the VG diagram, and there's actually the envelope. I'm just going to, somebody's popping up somewhere. Somebody else wants to join. Welcome. We talked about load with respect to airspeed and angle of bank at different airspeeds. Angle of bank, and how loading the aircraft to maintain level flight is the reason why the stall speed increase and the load factor increases. And we dissected that in detail. That's for a level turn. And we plotted that on the VG diagram and talked about it in depth. So there's a lot of information that we talked about. If you weren't in there 2 weeks ago, have a look at the video. It'll clear it all up. We tried to simplify it by talking about our stall triangle and the relationships. And we also talked about if you overshoot the center line, don't pull. Simply unload the airplane, roll wings level, and then apply full power, right rudder, climb away, and give it another go and get it right. So tonight we're going to talk about the top 5 inappropriate stall recovery techniques. We had a lot of fun doing this, and I hope Reagan has got on, because he tried to call Karen, and he's having trouble getting on, so hopefully he's on okay. So the top 5 stall recoveries, what I like to do is I'd like to just I'm going to stop presenting here for this at the moment, and welcome back everybody. I've got all the Brady Bunch squares here. I'm going to share the video, and I want you why isn't this showing up? Please excuse me while I figure out what's going on. And that's interesting. I'm just going to have to stop the show, and I wonder why that's not working. Stand by. I'll put this. Please bear with me. Technology is a great thing when it works. Here we go. Right, I'm going to share this video with you. It goes for 5 minutes. And then we're going to dissect each one as we go. So stand by. And we'll let you have a look at that. And I'll be back in 1 second. The premature staller. This is Neil Armstrong. Are you all settled in there, mate? Your harness is good? Yep, harness is all good. Oh yeah, we're going to clock watch that. You go. Right. This is half shot ball. Want me again? I was going to recover, but he didn't do anything. Oh, right, yeah. But there's a recovery. Right. Oh, yeah. Doing anything, he's going there. This is the fighter pilot. Yep. Like that. He wants to sit. Like that, with the cork around him. Yeah. I did that again because that was just fun. Well, we're going to do that one again, except we're going to do some really inappropriate control movements. This will be interesting. Okay. What we're going to do now is just bear with me a sec. What we're going to do now is I'm going to go back to the presentation and we're going to dissect each one independently. So if anybody's got any questions, you can just raise your hand. We've got 22 online. Welcome to the people that come on board. Reagan, I'm good to see you got on board, mate. Thanks to everybody else for joining in. So the top 5 inappropriate stall recoveries, and we'll just break them out. So we did all of these at 1G, wings level, at idle. It's the basic thing. And the reason why we've done this, the reason why I decided to do this is because these are the things that I see on a regular basis. I see all 5 of these things all the time. And we need, as if you're an instructor on board here tonight, hopefully this will help you out. And if you're a pilot, let's have a look at how we can improve things. So that's why we did this. So number 1 is the premature staller. So we'll just have a look at that, just this one section. And I'll pause it from time to time and show you what's happening. So we're reducing the power and applying a squeezer left rudder and increasing the angle of attack to hold the altitude, sacrificing the airspeed as the drag increases. And there's no stall warning. We don't actually get any buffet or a nose drop, and the pilot just appropriately releases the back pressure, applies power, and then climbs away. But the exercise was to stall. So now I've got to go to the next one next. So what's the problem with this one? Well, the aircraft doesn't actually stall. There's no stall warning, there's no buffet, there's no nose drop. The pilot's looking for those textbook symptoms: low airspeed, it's getting quiet, sloppy controls. That's all well and good for a wings level 1G straight ahead idle stall. The recover is normally appropriate, but it can be other types joined, as what we mentioned here. From an upset recovery perspective, this is really good because they've identified that there's an oncoming stall. They've addressed the angle of attack issue by unloading the wing and applying power and climbing away. That's really good, except the exercise was to stall the aeroplane. So what's the relationship that we're looking at here between the pilot and the stall? Probably, maybe the pilot's scared of and has an inadequate understanding of the stall, maybe. May have an inadequate understanding of angle of attack without actually getting to the critical angle. The focus is directed inside the cockpit. We're looking at all of these things inside the cockpit and listening and things. So it could be inappropriate or inadequate training. The top five, number 2 is the Neil Armstrong. Now, this is really interesting. We'll have a look at this. And I'm going to talk through it really quickly as it happens, because this happens in a very quick sequence. So the aircraft's going to reduce to idle, squeeze the left rudder to maintain balance, holding the attitude, increasing the angle of attack to hold the attitude. And as the aeroplane stalls, the pilot is just going to push the nose straight down because he wants that airspeed, and then he doesn't see it straight away, so he's putting the power on. The vertical speed here, if we look at the vertical speed indicator right here, come on, my little pointer, it's not going to do it. 2,000 foot per minute, but it's pegged, so we're probably going down faster. And then the recovery, if you look over the side here, that when we recover, it was like 2 plus G. So let's have a look at what this is. The aircraft does stall, but the recovery action is extreme. Looking for textbook symptoms? No, we're not looking for anything. We're just waiting for the stall so they can get that nose over and recover. They're probably really scared of the stall and just has to get that nose over. There's not a lot of learning going on here. We're not talking about reducing the angle of attack or unloading the wing. We're just punching that stick forward. The relationship: scared of and inadequate understanding of the stall, inadequate understanding of angle of attack, inadequate understanding of energy management. What's going to happen if we point that nose straight at the ground, and while we're pointing at the ground, we push the throttle to full power? Not only are we going to accelerate the aeroplane very, very quickly and lose a lot of height, but if we've got a fixed pitch propeller, we're going to possibly overspeed the engine. So there's a lot of energy coming into that. The focus is directed to get airspeed as quickly as possible. And again, maybe inappropriate or inadequate training. Number 3, the clock watcher. This one, a lot of things happen even a lot faster than for the Neil Armstrong. So we'll just have a look at this. Yeah, we'll do the clock watcher. Yeah. So reducing the power to idle. Again, squeeze the left rudder to manage the yaw rate for the power change. Increasing the angle of attack to maintain altitude. Airspeed bleeds off to the increased drag. You get a stall warning. Maybe I edited it out. Now, the airplane at the point of stall, the pilot's going to appropriately unload, but then he looks at the airspeed indicator and says, I don't have any airspeed, so I'm going to push the nose down. He looks at the airspeed indicator again. Oh, I still don't have any airspeed, so pushes the power. And now we've turned into a Neil Armstrong without the negative G. Have a look at the G meter on the right-hand side here. We're in excess of 2G in the recovery. Just really inappropriate and unacceptable. So what's the problem here? The aircraft does stall, but recovery is reactive and not intuitive. They're just focused on the airspeed indicator. No situational awareness. I just need to get that needle moving. The pilot-stall relationship, limited understanding of the stall. Inadequate understanding of angle of attack. Inadequate understanding of energy management. Focus is directed to reinstate airspeed. Inadequate understanding of the pitot-static system. I find this a lot with pilots. They just want to go flying. They don't want to know about how the airplane works. Knowing how the airplane works in the systems is going to save your life one day if you're unfortunate enough to get into a situation. The pitot-static system has 3 to 5 second delay, and when you're floating around near less than 1G, it's even greater time for the airspeed indicator to react. So expecting an instantaneous change on the airspeed indicator when you unload the airplane and lower the nose, it's just not going to happen. Again, inappropriate or inadequate training. Just before we move on, I just want to say that the Clock Watcher, when I made that video, that segment for this number 2, the Clock Watcher, or was it number 3? Maybe I got the wrong number there. But the Clock Watcher, I actually had to slow that video down. That segment of the Clock Watcher, I had to slow that down to half speed because there is so much going on so quick that I couldn't put the little pop-ups in because they'd just be a flash on the screen. So I slowed it down by half. So it's a very dynamic and very fast situation that can get you in trouble very, very quickly. So number 4, yeah, I got the number wrong. Sorry about that. Half job Bob. So what's happening here is this pilot is.
This is half job Bob.
He's actually unloading the wing and reducing the angle of attack.
He's going to recover, but he doesn't do anything.
But that's all they do. So let's have a look at what's happening here. So we've got the power to idle.
Recovery.
Lowered the nose, but then the power hasn't changed and the nose is just flopping around in the level attitude, and we're just feeding off that drag and the aircraft's descending. So there's not a lot of stuff happening there. So the problem is the aircraft stalls, recovery is initiated, but it's not completed. The pilot recognizes the symptoms of the impending stall, which is good, but does not identify or correct the established sink rate after the initial recovery. So the relationship the pilot has with the stall here is an inadequate understanding of the stall, inadequate understanding of angle of attack, inadequate understanding of energy management. The focus is not directed at unloading the wings and returning to a stable aircraft state. Now, if there's instructors on board here, and you need to start using these terms about stable aircraft state. And the best stable aircraft state is straight and level at cruise power with the level attitude, so that you got level flight. For this half job Bob, is it startle and surprise, or is it information overload, or is it freezing? I don't know what's happening here. So again, inappropriate or inadequate training for them to overcome and manage the startle, surprise, or the freezing activity. Number 5, this was just really good fun. The fighter pilot, I see Peter there, he's tuned in and he's laughing because he was sitting in the back. So the fighter pilot here, we'll just have a look at this. This is where the pilot.
This is the fighter pilot. Yep.
The stall happens, and they just hold the stick in the stall stick position and just put the power on. And there's a lot of things happening here. So the aeroplane's going to stall, and you'll see here in the top left picture. So there's the stall, And oh, you didn't freeze. Hang on a sec. Let me just go back. Sorry about this. I'm going to go up here. So there's the nose high attitude. Have a look at the position of the elevator on the top left screen. And then as the aeroplane actually stalls, you'll see the nose drop. Here it's, there's the nose drop. It's starting to drop now, but have a look at the position of the elevator. Now have a look in that picture. The elevator is full up. The stick is back in the stall stick position, which is back on the back stop. Now you'll see the aeroplane has dropped the left wing and it's actually yawing. If I go forward just a little bit more, if you can see it really closely there, you'll see the rudder is still neutral, but the aircraft is yawing to the left and rolling to the left. And that's because of the P factor and the torque and the slipstream and the gyroscopic effect. We call them tags: torque, asymmetric blade, gyroscopic effect, and slipstream. Now it's yawing the aircraft to the left. That's the primary effect because of the tags. And then the subsequent second effect of the yaw is the roll. Now, the pilot, the pilot is still got the stick back because they're probably confused, and then they're using controls to try and get it under control. But this engine is just trying to get them out of it. They're trying to do the fighter pilot thing, it just got all out of shape and very uncomfortable. Here we recovered. So the problem here is the aircraft stalls, but the pilot does not reduce the angle of attack by unloading the wings. They hold the stick back. Application of full power without addressing the stalled condition is the problem. They've identified the stall, but they've just put the power on without reducing the angle of attack. No situational awareness, does not identify or correct the stall stick position. If your stick is back against your guts, you are going to stall. It doesn't matter how much power you got. So the stall relationship: inadequate understanding of the stall, no understanding of the angle of attack, inadequate understanding of energy management. Focus is not directed at unloading the wings and returning to a stable aircraft state. Startle, surprise, information overload, or freezing, same question. Results from inappropriate or inadequate training. And the bonus one, well, that was just so much fun that we just went, you know what, let's just start flopping those controls around, trying to fix it with aileron only. So this is exactly the same. We stall the aeroplane, leave the stick in the stall stick position, apply full power, and then just use aileron to stop the wing drops, and this is the result. So again, you see the elevator in the full back position. Put the power on, yaw to the left, roll to the left, right aileron. Oh, doesn't like that, rolling that way. I better put the aileron back the other way, stall the outer wing, and over she goes. Thanks for coming. And then, of course, the untrained pilot sees a screen full of planet Earth and just keeps that stick back. And that's pretty much where most people see the end of their flying career in their life, unfortunately. So moving on, I'll just get out of this. What's the problem here? Same thing. Didn't unload the wings, didn't address the stall condition, did not control the pitch or the yaw. All right, imbalance. Inappropriate aileron to use to correct a wing drop. No situational awareness, does not identify or correct the stall stick position, and uses aileron out of balance at high angles of attack. Big no-no. So the relationship is the same situation we got. And inadequate understanding energy management, inadequate understanding of aerodynamics. I really see this, and when I start quizzing people about understanding the purpose of the horizontal stabilizer and the downforce and how the manufacturers correct for power, the tags, and balance of the rudder, there's a severe lack of understanding of that. Focus not on returning to an aircraft stable state. And pretty much everything else is the same. So we did all of those at straight and level flight. And that is the most basic stalling exercise, 1G, wings level, idle stall. But that's not where we get in trouble. These are the exercises where you get in trouble. Now, for those who weren't with us 2 weeks ago, this A5.1 stall under the following conditions, A, B, C, D, E, they are the Part 61 MOS requirements. Everybody should be doing stall recovery training for all 5 of those to a competent level. And I've spoken to many people, and I know I did a flight review with one of the people tuned in here, and he told me he'd never done a stall and a turn. I got another guy who's a flight instructor on board here, and he told me he hasn't done a stall and a turn. So the instructors aren't giving all the information and the assistance that everybody can get. As a matter of fact, Stan, I think the one I was talking about with you the other day is the Neil Armstrong. That's the one that was really fun that we were talking about the other day.
Yeah.
So what is appropriate? We've been talking about the inappropriate ones. What is appropriate? Now, what I'm going to talk about here is not how to recover from a stall. That's in the MOS and the flight instructor manual. All right. But I'm going to talk about considerations here. So, number 1, reduce the angle of attack. Reduce the angle of attack. And how about we reduce the angle of attack? And just for one more time, we'll reduce the angle of attack. That's the very first thing you must do, no matter what aeroplane you're flying. You need to consider what the energy state is of the aeroplane. Am I in a nose high and I'm depleting energy because I'm in a nose high condition? And what's my power setting at that time? We need to prevent further yaw with appropriate rudder. If you stall with the ball out of balance, you will drop a wing. And you need to correct any further yaw with appropriate rudder. And picking up a wing with rudder, well, we'll talk a little bit more about that in a minute. Roll wings level with aileron and rudder in balance after you've reduced the angle of attack. So in the fighter pilot bonus, we were using inappropriate use of aileron at high angles of attack. However, you can use aileron and rudder in balance normally if you have reduced the angle of attack well below the critical angle. And that's more effective than trying to yaw the aircraft at high angles of attack. Return the aircraft to a stable aircraft state. That's normally the level attitude. Put the airplane in the level attitude, apply cruise power, balance the airplane will fix itself. Simple as that. Do you need to climb? Well, if you stall the airplane and you encounter an upset, or you stall the airplane at 9,500 feet, there's probably not an immediate requirement to climb. So you could return the airplane to a stable aircraft state in the level attitude. However, if you stall the airplane in the circuit, you probably want to think about applying full power and manage the pitch, manage the yaw, and climb away. What is my aircraft energy state? We're going to talk a lot more about that in a couple of minutes. Apply power as required, but you must control the pitch and control the yaw. And this comes back to the aerodynamics. A poor understanding about what that horizontal stabilizer does for the aeroplane when you're pushing the throttle forward and back above cruise and below cruise, and what is the ball doing when you're changing the power of the aeroplane. So you might do some research and read a lot of things about upset training is totally transferable across any platform that you're flying. Well, I would agree with that, but there's two parts to it. The aerodynamics of the training is totally transportable. In every instance, lower the nose and reduce the angle of attack is the immediate action. However, is this transportable for every single type of airplane? So let's have a quick look at that. Different aircraft have different energy states. If I'm flying a King Air or a really large aeroplane that weighs 5,700 kilos, so anybody who holds a PPL can fly an airplane 5,700 kilos, and you get out of that and get into a drifter, it's a completely different energy state. The airspeed range of a drifter, I can't remember the V&E data. It's like really low to about 85, 90 knots or something. PJ, could you just turn your camera off for a sec, please, mate? And yeah, best aircraft ever. Yeah, I know, mate. It's good. So you need to manage the different performance levels of the airplane, because something with high weight, high inertia you got a lot more time to do things than you do with a low inertia, high drag airplane. Different aircraft have different control loads. Some airplanes are really, really light. Some airplanes are heavy. Some airplanes are heavy and roll, light and pitch. Some are light and pitch and heavy and roll. So they are different. Different aircraft will require different control input rates, which means if I stall the airplane and I need to lower the nose, how fast I need to move the stick forward may be different for each airplane to achieve the same result. Different aircraft will have different configurations, pusher, puller. Now, Dita, you'll be nodding. When just going to admit Gary, if you're flying an airplane that's a pusher, like a drifter or what's the float plane? The Renegade, it's got a high thrust line and a low drag line. When you apply full power, the nose is going to pitch down first and then it'll pitch up. You reduce power, it's going to pitch up and then it'll pitch down. So recovery techniques as far as the stick usage is very different compared to a tractor type aeroplane where you pull the power back, the nose pitches down. So additionally, we need to think about these. The same aircraft may require different control inputs depending upon the energy state at the time of the upset. Now, Peter and I went out and had a bit of fun in the decathlon, and we stalled the aeroplane in a nose down increasing airspeed, and we stalled the aeroplane in a nose high depleting airspeed energy state. Now, when we recovered or tried to reduce the angle of attack in the nose low increasing airspeed state, the controls are more effective, so we only needed to move the controls a very small amount to reduce the angle of attack. However, with a nose high attitude, where we have a rapidly depleting airspeed, we had to probably nearly push the stick all the way forward as the aeroplane was coming back to the stall. And so we had to have a massive stick movement. A same aeroplane, same stall condition, different energy state, different control inputs. So while we can say UPRT training is totally transferable, the theory of it is, but the way that you do it for each different aeroplane in multiple different energy states configurations will be different, and you've got to get to know your aeroplane. So loss of control doesn't give you time for a hassle check. We talked about tonight all those things at 1G, wings level, idle, stall. That's not when it happens. It happens when you're turning the aircraft, you're maneuvering the aircraft, and you're pulling on that stick to try and tighten the turn, or you're just having a bit of fun around some cloud, 3,000 feet clear of cloud, Your Honour, and you just go that little bit too far and you're out of balance, and then all of a sudden you're in a situation. It doesn't alert you to something happening if you're not aware of it. But if you are aware, if I keep pulling the stick back, I'm going to stall. Why am I feeling like I'm loading? What is my energy state? Oh, I don't have enough energy. I better unload the stick and get a bit more energy. These are the things that we need to be considered. So your aircraft and the environment that you're flying in will give you many warnings of an impending loss of control. You just need to have the appropriate training to understand that. Loss of control prevention training, or UPRT, is pretty new. It's really come to the fore after Air France 447 and the Coghlan accidents, and it's been driven by the airlines. But the problem is it also affects GA and RA. And as a matter of fact, in the US, there are more deaths in GA and recreational flying than there are in commercial flying. They got a bigger number of people, but the ratio still remains the same. So we need, as pilots, recreational or professional, or instructors, we need to understand what's going on. So what do we need to know about loss of control training? It's going to be a heightened awareness to the potential threats. It gives us effective avoidance. An early indication and correcting for this will prevent a potential upset. However, that old saying, the pilot uses his superior knowledge to avoid conditions where he needs to use his superior skills. If you do need to recover and you don't know how to recover appropriately, like that bonus fighter pilot recovery, if you don't do it correctly in the appropriate time, then you're going to be in trouble. As a matter of fact, the heightened awareness, these two here, the heightened awareness and the effective avoidance, there's quite a bit of time for you to assess what's going on. But once you get to a upset and you need a recovery, you've only got between 3 to 10 seconds to do something, and you need to do it in the correct sequence, in the correct order. And if you don't know how to do that, you're in trouble. It's definitely not aerobatics. Aerobatics is about intentionally upsetting the airplane for a maneuver. What we're talking about for loss of control, prevention training, and UPRT is about what to do if we are an uncommanded or an unintentional upset. So there's lots of resources. If you're a flight instructor or a flight school, or you're just really interested, there are a bunch of resources. Now, I've been working with Neil Schaefer. I'm not sure if Neil is still on here. There's still 22 people on board, so hopefully everybody's still interested. It's good, the number's steady. G'day, Neil. How are you, mate? Neil and I have been working on this for half a decade, mate. It's a long, long time. There are a lot of resources out there, and we've been working with CASA to make moves forward to get the right information and the right training. The ICAO Doc 111 is pretty much the Bible on what's going on, but that's written for airline things, airline operators. FAA has a couple of few ACs. EASA is the only regulator in the world that has mandated upset recovery training for commercial pilots under this FCL 745.A document. We're talking with CASA about the importance about getting that in here. Neil's done a great job. There's a core group of people passionate about upset recovery, and we're all trying to make good information. From as far as CASA is concerned, AC 12103 is the guidance material issued by the regulator. Now, if you're a flight school or a flight instructor that delivers aerobatic training, and you think about, I might like to give this upset recovery thing a go, please read these documents, because it's not just a matter of adapting a aerobatic training syllabus. It is far, far from that. There's a lot more classroom, a lot more understanding about systems and aerodynamics at an appropriate level, and then going out and putting those into practice. Again, these documents are written for commercial pilot, multi-crew licenses and high altitude airliners. But people like Neil, myself, and a few others, we spent hours and hours and hours and days and weeks and months trolling through these and picking the bones out and saying, this is appropriate for, let's put some appropriate stuff together for recreational and GA training. So the training process is academic training and practical training on aeroplane. We don't have any 172 simulators that can do this type of work. Again, it's an airline document, remember. What the training does include is aerodynamics, G awareness, stall spin, the theory about it, how to avoid it, what you're going to see, recovery techniques, reviewing accidents, why did this happen, what could they have done different, energy management, human factors, and flight path management. And once you get onto the aeroplane, it's about getting in touch with the aeroplane and understanding how it works. There's those exercises there, again, derived from the ICAO Doc 111 down there. Lots and lots of mountains of information. And I pick up something that I read 2 months ago, and I find something new all the time. So from an instructor point of view, Neil and myself and RA Oz with Jill Bailey, we did a whole bunch of exercises over a 3 to 4 day period a few years ago. How can we put this into training so that ab initio at pre-qualification people can do things? So CASA asked me to put together something to do with what would the instructor, or what would UPRT training and instructor development look like? Because we identified that the instructor's the key, the linchpin on making sure that people are trained appropriately. So if the instructors can't, if the instructor feels unsteady and unsure and nervous at the stall teaching a student, the student's going to pick up on that, and they're going to feel unsteady, and so it all just doesn't become very effective. So this is something that I've been working with CASA, and it has components about what Neil and I and Jill were working on a few years ago. And we've labelled it a little bit, I've labelled it a little bit different: loss of control, in-flight prevention training. And this could be an add-on like threat and error management and airmanship, so that on each element of your flight training before you get certified or licensed, then we are going to talk about what are the likely upset events that could happen here, and what are we going to do about it. So loss of control in flight prevention training part 2 is for people who have already got the qualification, you're already licensed, you're already certified, and you want to go out and learn about it more, and improve your skills and get some coaching and become a better pilot and a safer pilot and understand your aeroplane some more. UPRT training for commercial pilots, full UPRT training equivalent to the EASA FCL 745A. Again, that would be in an aerobatic aeroplane. I must make a caveat that in loss of control in-flight prevention training part 1 in the pre-qualification, you would only do exercises up to the ability of the certification status of the aeroplane. You're not going to do spins, you're not going to do things like that, but certainly unloading and understanding stalls and a turn, they are all capable of being performed in those training aircraft. Now, moving on, where does the instructors go? Because the instructors are, it's a very, very important piece, component of the effective training, that the instructor is capable of doing it. So I've got a number of instructor levels here. So if you're a flight instructor, and let's say you're a newly minted RAOS instructor or a GA instructor, and you're all ready to go out there and get amongst it and take these new students out, they're going to frighten the bejeez out of you. They're going to do things that are going to catch you by surprise and possibly put the aeroplane in an inappropriate aircraft state, and you need to be able to get it back. So a loss of control in flight prevention training instructor basic course could be for the flight instructor's personal development only. I've had a number of flight instructors who've come to do training, and they've just presented themselves and said, look, I just want to know how to fly the aeroplane better in unusual attitudes, because I've had some students do some funky things and I felt a really bit nervous, so I want to know a little bit more. So that would be something for their own development. The next one would be a loss of control in flight prevention training instructor. So this course is how to teach pre-qualified pilots those loss of control in flight prevention techniques during their pre-qualification training only. And it would be something similar to when you become a flight instructor in GA and you want to teach basic instrument flying. You can't do that until you've done a training course on how to teach basic instrument flying. So that would be like that sort of qualification. You can't just say, oh, you're a flight instructor, now go out and teach loss of control during the pre-qualification elements. It's very important that they get taught the appropriate way. UPRT instructor would be somebody who can deliver pre-qualification, post-qualification, and commercial pilot UPRT, and that would be in both aerobatic aircraft and also like the post-qualification. Somebody owns an RV and already done some. Phil, we've touched on it, and Dave, you're talking about wanting to do it in your RV6. Somebody comes along and says, oh, look, I want to do this to feel better in my own aeroplane. Now, RV6 is probably a poor example of this because it is fully aerobatic. So let's say somebody owns a Cherokee 140 and they say, I want to learn about upset recovery. And say, well, we'll do a little bit in the aerobatic aeroplane, but then we're going to go do some stuff in your aeroplane so that you understand what's going to happen if you let that wing drop too far, because we're going to do it in the aerobatic aeroplane. We'll just let it roll over on its back and see what happens. But we won't do that in your Cherokee 140 because it's not certified for that. But we need to identify, hey, look, if you let this go too far, see what's happening here. Now you need to correct it by doing this. We can prevent the aircraft rolling on its back by understanding what the individual aircraft does. The UPRT instructor trainer would be somebody who would teach the three preceding instructors. That's basically somebody who just lives their life inside out, upside down, and flying around the stall. And I'll tell you, towing banners, spend a whole bunch of time just a few knots above the stall, as slow as you can get with a big bag of drag out the back. And if you don't know what the hell's going on with angle of attack there, you're going to get in trouble really quickly. So you'll notice there that all of these X's, none of these things are mandated, but they're recommended. And again, people like Neil and myself and others, we're working with CASA to try and find the best way forward so that it's not arduous, but it's relative and effective. So that pretty much wraps up. Coming up for some more, we've got some online courses from an operational point of view. I've got a series of 3 things every pilot needs to know. It's talking about trimming, constant airspeed, and again, the stall. And then another one, which is really a lot of fun, is fly almost an airplane like a pro in 10 minutes, but you had to have done the 3 things every pilot needs to know before you do that. From a maintenance point of view, Aircraft Owners 101, we talk about your responsibilities and things that you need to know about owning an aeroplane, and tips and tricks on how to save some bucks and keep your aeroplane safe. CASAR Part 43, we're working pretty hard on AMTC training, maintenance training for AMTC 3 and 4. So it's keeping us really, really busy. At our airfield, we do personalised pilot coaching. Not only do we do RAOS, RPC training, RPL, PPL, CPL, we do cross countries, we do CTA, CTR, spin, aerobatics, formation, tail wheel, and of course the complete UPR training on our aircraft, all yours. Subject to, if you bring your aeroplane, I will be doing a airworthiness inspection and audit on your records. At your airfield, I'm happy to come and have a chat and talk about a whole bunch of things and tailor it to what your group would like. Talking to a group down in Adelaide at the moment about getting some instructors and getting them up to speed with some of what we've been talking about. Loss of control, RA and GA specific, maintenance management support, a whole bunch of stuff. So that pretty much, thanks for listening. We only lost one. If anybody's got any question, I'm sorry, I didn't read these notes. I was too focused on. Neil, you've said through the work we feel we've done a great job scaring pilots on stalls, but in closing our eyes and avoidance, what we missed, the most important thing is understanding, keep up the good fight. Right? Yeah, it's like I think I mentioned in the UPRT conference, Neil, talking about loss of control is like the continual don't use your phone while you're driving campaign. It's not something you just say once. We have to keep talking about it, and using the appropriate terminology. And if there's instructors out there, don't say, oh God, we're going to go do stalls. Oh, I hate that stuff. That's really bad transfer of energy. Use terms like unload and stable aircraft state, and get in tune with what's coming down the pipe so that we can keep people up to speed. Stan, AMTC, have a read of, there's a, pardon me, there's a new CASAR coming out, CASAR Part 43. It's a proposed thing. Have a look at that. I can flick you some information on that, Stan. And it talks about maintenance for certified aeroplanes and light sport aircraft. It's a bit of a interesting debate over a beer and a steak, for sure. Jennifer, it's concerning to learn that some schools instructors are not teaching stall recovery as per the CASA syllabus. Oh, Jennifer, I fly regularly with commercial pilot, newly minted commercial pilots who come, and I had a guy about 3 or 4 weeks ago did the whole Neil Armstrong on me, and he'd done upset recovery training somewhere else, and he did a Neil Armstrong on me, and I'm just like, dude, what are you doing? And then, you know, unable to, commercial pilots who are and flight instructors who are unable to identify the difference between a slip and a skid, and what's more dangerous, a slip or a skid. And they got a 50-50 chance and they blow it. So it's it is pretty scary. The other thing too is I'm not sure if there's any CASA examiners on here as well, but people who are getting their licenses or certificates, you're putting your name on these people and you're saying that they're okay to go. And, if you let somebody go who you think, well, he doesn't really know that, but I think you'll be okay, you're going to have to live with that if something happens. So it is a problem, Jennifer, and it's about educating people and, just instilling the professionalism and the duty of care. It's pretty important. Anybody else got any questions? I want to thank you all for tuning in, and I will post the video up, and if you could share it around, keep following us on Facebook and stuff. I'll put up some more stuff that we're going to do. Like I said, the three online seminars. And if you need anything, just give us a hoy. If nobody's got any other questions, I'll thank you very much. I bid you adieu and see you around the sky.
Great job, Paul. Thanks, mate.
Thanks, Neil.
Thanks, Paul. That was good. So,
Thanks, Stu.
Thanks, Paul.
Thanks,
Thanks
James.
again,
Mate.
Great show.
Thanks, Paul. Very well done, mate.
Thanks, mate.
Yep, thanks, Paul.
No worries.
Thank you, Paul.
Cheers. The unknown pilot. Yes. Very good. Intrepid aviator.
Yes, mate.
Thanks, PJ.
Awesome.
Thanks, Peter.
Yep, thanks very much. That was good.
You're welcome, mate. Thank you. Kane, you're still here? You still awake, mate? Oh, no, he's gone. QDP team. Yeah, cool. All right.